Good morning, dear colleagues. Glad to participate in the conference. Let me introduce myself. My name is Dmytrenko. I work at National University, Yuri, Kondratyuk, Poltava, Polytechnic as associate professor at the Department of Oil and Gas Engineering Technology. My aim for today's presentation is to give you information about the use of bischofite in the gas industry as the inhibitors of hydrate formation. Extraction and preparation of gas for transportation is complicated by dehydration and corrosion of metal equipment. World domestic practice shows that one of the simplest, most effective, and in many cases cost-effective methods of combating the processes of hydrate formation and corrosion is the use of inhibitors. The technologies based on the use of complex inhibitors are more efficient. In the temperature climate of Ukraine, the use of electrolyte solution and inhibitors of hydrate formation is relevant. Bischofite solution is the most effective reagent among electrolytes. The projection resources of bischofite within the Dnipro basin alone are about 10 billion ions. The use of bischofite in gas production companies is often limited due to its irritational use. So, the purpose of the study is prevention of dehydration and carbon dioxide corrosion during the operation of gas condensate fields by the use of domestic available inexpensive raw materials instead of expensive methanol and corrosion inhibitors. Bischofite solution with mass fraction of magnesium chloride 24% from well number 1 of the Turin area were used in the carrier of the complex inhibitors. Studies have been conducted to determine the complex action of bischofite and surfactants on the process of hydrate formation. Propane was used as a model of hydrate forming gas. The process of hydrate deposition was studied under dynamic conditions on experimental setup. It was found that the introduction of a complex inhibitors based on bischofite with cationic surfactants Kappa at K1M, the temperature of deposition of hydrates decreased by 6 degrees Celsius. Hydrates is formed in the solution surface and on the walls of the reactor. The adhesion of such hydrates to the reactor is negligible. In a distilled water control experiment, the hydrates is formed as a solid throughout the volume of the liquid-filled reactor. A similar hydrate was obtained from bischofite. Our data are confirmed by studies of the other authors. In order to eliminate the main technological shortcoming of bischofite, a number of laboratory studies was carried out. The corrosion research takes into account the main factors that can significantly affect the corrosion process industrial condition. Namely, in the presence of aggressive components, carbon dioxide as a gaseous medium, hydrocarbon environment, a light condensate was used as a hydrocarbon phase, turbulent flow regime. Bischofite solution with the addition of acetic acid was used for the study. Concentration of acetic acid was chosen because of the maximum low molecular weight carboxylic acids content in the formation water and northern Ukrainian wells. Corrosion studies were carried out by gravimetric methods of the thermostatic installation. It was found that cationic surfactants Ki1M and Stantex are the most effective surfactants for bischofite solution at a concentration of 1 gram per decimeter cubic. This reagent have a degree of metal protection of more than 90% in an environment with carbon dioxide. The other reagents have a lower degree of protection. Produced formation water is corrosive aggressive phase of extraction fluid. So the efficiency of complex system in relation to simulated medium of formation water is determined. The obtained data show the bischofite solution inhibits the process of carbon dioxide corrosion. All complex systems under study provide a degree of metal protection over 90%. Though the most effective carbon dioxide for bischofite solution is cationic surfactants Ki1M. When choosing an iron stabilizer, a number of organic and inorganic acids has been studied. The study found that the most effective reagent are IDTA, oxalatic, and citric acids. For the final choose, after corrosion studies, we choose citric acid. Further research was aimed at removing surfactants from bischofite solution. As can be seen in figure, the positive effect of surfactants additives is obviously. So much of the presence of these reagents, the precipitate is formed in the form of fine dispersion. Precipitate with the addition of apotheric surfactants have a visually smaller volume compared to the control experiment, and with the addition of cationic surfactants, more fragile structure. The degree of precipitation calcium sulfate you can see in this rate, and the amount of sediment and the contrary increase in the sodium. The results of study of the interaction of stabilizer of iron ions and surfactants have revealed the mechanism of action of the latter. It has been determined that 2xM as and KPB have a complexing effect on alkaline earth metal ions. This is confirmed by the fact that in the presence of strong acids, the degree of precipitation calcium sulfate decreases sharply due to the destruction of complex compounds, supersaturation calcium chloride solution, and precipitation of chlorides. The introduction to complex KPB in sample with stabilizer of iron ions caused a decrease in the volume of sediments. According to the results, it is recommended to use surfactants KPB-10 capable of complex action as catalysis for the deposition of sulfates. According to the results of laboratory studies, the following compound is composition of the complex inhibitors of hydrate and corrosion of Zerosine. As a result of industrial tests, confirms the effectiveness of the technology of corrosion prevention and hydration with the use of these complex inhibitors. And in conclusion, it was found that the introduction into the solution of bischofite amphoteric surfactants KPB provides a decrease in the temperature deposition of hydrates by 6 degrees Celsius and increase the degree of precipitation calcium sulfate by 76%. Cationic surfactants Ki1M high degree of metal protection against corrosion. C3C, the degree of retention of iron ions, 96%. Secondly, based on the bischofite solution, a new formulation of complex inhibitors of hydrate formation corrosion was developed. Thirdly, industrial tests showed the introduction of technology schemes for the use of complex inhibitors based on bischofite allowed to obtain the annual economic effect to the use of cheap raw materials, reduction of the number of injections of two inhibitors, and significant environmental effect due to the prevention of pollution of petroleum products and disposal of used reagent. Thank you for your attention.